speaker, Neslihan Nesliye Pelen from the Samsun, Turkey, with the presentation entitled by Vector-Borne Disinformation During Disasters and Emergencies.
Thank you.
Hello.
Hello. Can you see the page?
Yes, now we can see your presentation. Can you make a full screen?
I try now.
From görünüm. Yes.
Now it's okay.
Yes. Yes. Now we are ready to listen to you.
Thank you very much. In this talk, I will give you some information about the vector-borne disinformation during disasters and emergencies. First of all, I will make a small introduction about that topic, and we will try to design a system to explain this explain the vector-borne disinformation. Then we will try to make the mathematical analysis of that system, and at the end I try to share my numerical results with you. First of all, the vector-borne disinformation model is a type of rumor model. Therefore, I very briefly want to talk about SIR models, because SIR models are the initial point of these kind of systems. SIR models is the first epidemiological model that describes the relation between the compartments, susceptibles, infected, and removes. These models was first mentioned by Kermack and McKendrick in 1927, and now many epidemiological models are studied today. These studies mainly inspired from that model. After a while, Daly and Candy realized there is a similar transmission between rumor and transmission of rumor and transmission of the illnesses. Therefore, they design another model which is very similar with the SIR models, and their model's name is the ISS model, which is also a compartmental model, and the compartments in that model are the ignorance spreader and stiflers. After their research, again, many researchers start to make studies on rumor models. In the literature, you can find many examples of that models. And in that study, what we are doing is mainly settle the relation between vector-borne diseases and the vector-borne disinformation. Here in our study, the social media behaves like a vector while rumor is spreading in our system. And therefore, we adopted our rumor model on vector-borne diseases. Very briefly, what are vector-borne diseases? Vector-borne diseases are the diseases that are caused by parasites, viruses, or bacteria that are transmitted by a vector, such as mosquitoes, ticks, flies, tritium bugs, so on and so forth. Also, researchers indicate that the vector-borne diseases spread to non-endemic regions because of the globalization and climate change. And this phenomenon is not very different for the vector-borne disinformation models because of the social networking elements. And also, while designing our model, we assume that each short message or video distributed by social media users are denoted as a bite of a mosquito. And therefore, an infectious vector causes consciously disinformation or unconsciously misinformation, and this causes an outbreak of info pollution locally or globally. Now, we come to the mathematical modeling of vector-borne disinformation model. For that reason, firstly, we assume that there is a wrong information about the COVID-19 pandemics that is available on these social media elements. And this wrong information is transmitted by the vectors. In other words, here the vectors are the messages. They are transmitted with the social media elements. These messages are transmitted with the social media elements. And here we define two types of populations. First one is the human population, and second one is the vector population. Human population is divided into 4 compartments, and vector population is divided into 3 compartments. The compartments in human population are the compartment of S. This contains the people, this is the susceptible population, and this contains the people who are not aware of the wrong information. The other compartment is the E compartment. It is the exposed population, and it includes the people that are received message, wrong message, but they still doesn't transmit it yet. The compartment I, it is included the infectious population, and the individuals in that compartment spreads the wrong information directly or via social media. And the last compartment in the human population is the compartment of R. This contains the people recovered. This is a recovered population, and this contains the people who forgot the wrong information and they are available to be infected again. When we come to the vector population, this is denoted with NV, and it is includes 3 compartments: SV, EV, and IV. The SV compartment is the susceptible vector population, and it denotes all the information sources in the social media at time t. The second compartment, EV compartment, is the exposed vector population, and it includes all the loaded wrong informations in the social media elements, but these messages does not transmit it yet. And the last compartment is the IV compartment. It includes the infectious vector population, and these messages spreaded wrong information in these social media networks. And while settle the system, we ignore the direct transmission between humans for that system. And now, after talking about the compartments, it's important to understand the relation between the compartments to obtain the system. Very briefly, I want to talk about these relations. First of all, a social media user in the compartment S attacked by an infectious vector IV. What does it mean? It means that any people in the compartment of S, any person in the compartment of S receives the wrong information, and then he or she take this wrong information, but there is but he or she doesn't decide to transmit it yet. Therefore, he or she is in the compartment of E, and a similar mechanism is also true for the vector population part. Therefore, a person or a device, in the non-infectious phase has the information, but still it is not shared yet. And also, some conscious individuals do not prefer to share an unconfirmed information who are directly transferred to the compartment of R. And also, we assume constant recruitment and death rates for the human population and vector elements. Also, because of the high number of people and high number of vectors, we use saturation elements, saturation points, and we also include these terms into our system. Let's talk about the follow chart of that system. Here you can see the attraction between the IV compartment and SV compartment. After that initiation, you can see here the follow up to the compartment of R. And also we have said that some conscious people who are not, decide not to share the unconfirmed informations, they are go to immediately from the compartment of E to R with a rate of theta. Also, we have said that some people starts to forget what they have taken before, and therefore there you can see a follow from the compartment of R to S because of that reason with the rate of gamma. Also, there is another interaction between the compartment of I and S. After that initiation, you can see also the follow from EV and IV, and also we have said that that rate of humans, which is denoted with mu v for each compartment in the human population, and you can see here the deceleration rate of the vectors with the rate of mu v for each vector compartments, vector population compartments. Here, according to that follow chart, we obtain system 1. Here, system 1 is the model that explains the vector-borne disinformation, and we combine this system with the initial conditions that you see in 2. First of all, we try to explain the existence, show the existence and uniqueness of system 1, and to show that one, we define the following iterative sequence in 3, and this first lemma says us the solution of system 3 with the corresponding initial conditions in 2. Each term of this sequence is bounded from above and below with non-negative constants. It has a very simple proof. This proof is mainly based on mathematical induction, and since we take our initial conditions non-negative, automatically when we take m is equal to 0, all the conditions or the necessary how can I say that what we want is obtained when m is equal to 0. When we take m is equal to 1, or we come to the initial step by using these conditions on the initial initial conditions and the other parameters, we obtain for the last sub-inequality of system 3, this last sub-inequality of system 3, we obtain this result. Making the necessary calculations, we immediately see that IV1 is less than or equal to that term, but bigger than or equal to 0. Very similarly, but when we do the similar things for the other sub-equations, we obtain that when m is equal to 1, the compartments are bounded from above and below with non-negative constants. And when we come to the induction step, we assume that these compartments, when we take m is equal to m, they are bounded from above and below with non-negative constants. And applying these similar calculations to that induction step, we obtain that all the compartments of system 3 is bounded from above and below with non-negative constants when m is equal to m plus 1, and this gives us the desired result. I will use one fixed point theorem to show the existence and uniqueness of the system 1. Therefore, I want to very briefly remind you that theorem. And theorem 2 says us the solution of system 1 with given initial conditions in 2 is exist and unique. How we prove this existence and uniqueness? To prove the existence of uniqueness for system 1, we should have to show that system 3 is a Cauchy sequence. For this reason, we should have to use maximum norm. and we take the difference of m+1 and m terms, and after using the Gromov inequality and lemma 1 I have just mentioned above, by using these tools we get the desired results. Very briefly, I want to explain this one. We take this difference using Gromov inequality, obtain, and after using maximum norm, we obtain inequality 4. Very similarly, we obtain 5, 6, 7, 8, 9, 10. We add up all of these and take that inequality. In that inequality, the D1, D2, D3, D4, 5, 6, and 7 are defined as like that. By choosing T small enough and AI less than 1/3, we and using Banach fixed point theorem, we can obtain that system tree is a Cauchy sequence. And since the convergence of the sequence of system 1 is obtained as a result that system tree is a Cauchy sequence, we get a
I think there is some connection problems with Neslihan Hoca. Let me wait a little bit for connecting again.
can you hear me?
Yes, we can hear you.
I'm very sorry. My charge is off. I'm very sorry. I didn't realize that.
Okay.
I can continue if
yes,
it's okay.
If you are ready, you can continue, but you have only 4 minutes to finish your presentation.
Okay, I will finish. I will finish.
Okay.
Just a minute. And in that theorem, we obtain the non-negativity of the solutions. It's not full screen.
No. You are not sharing your screen now.
Oh, I'm sorry. Just a minute. I think now it's full screen. No, sorry, now full screen. It's okay now?
Yes, now it's okay. You can please.
Yeah. In that theorem, we can show the boundedness of the parameters here. I very briefly want to talk about the disinformation free equilibrium point. Disinformation free equilibrium point is that point here. By using the Van den Drieschen method, the next generation matrix method, we obtain the basic reproduction number R0. For that reason, we define such a vector and curly F and curly V vectors. Here, F represents the inflow of the new infections, and we denote the outflow from the infectious compartments. And you see here the Jacobian matrices of curly F and curly V. By after obtaining its Jacobian matrices, we obtain the next generation matrix, which is F V minus 1. And since the basic reproduction number is the spectral radius of the next generation acceleration matrix, we obtain R0 as that one. Here, theorem 5 says us if these two conditions are satisfied, then the equilibrium X star, or disinformation-free equilibrium point, is globally asymptotically stable. To obtain this result, we use Lyapunov stability theorem and LaSalle invariance principle. After using these ones, we obtain the global stability of the disease-free equilibrium point. And when we come to this information equilibrium point, after the necessary calculations, we obtain X star star as this way. Here we define PC and RV as that way, and PC is bigger than 0 because of that reason. With a small calculations, you can obtain these results immediately. And also for this sensitivity analysis, we calculate the sensitivity index of R0 according to the parameters in the R0, and therefore, according to these, we obtain these index formulas here. Before the numerical simulations, I just very briefly show you the parameters and their estimated values. These are obtained from several articles, several studies. And here you can see our numerical simulations. These numerical simulations are done according to the change in theta and beta. What is beta? Beta is the transmission rate, and theta is the rate of choosing not to spread an untrusted information. Here you see, although R0 is less than 1, there is not gone to the disease-free equilibrium point for the number of whisperers or eyes, because this one does not satisfy the conditions of theorem 5 I just talk about now. But when you take beta as 10 over minus 7, you see down to the equilibrium free, disinformation free equilibrium point, because it satisfies the conditions of system 5. And very similarly, when theta is changed, you obtain these results. And here the sign of indices, and these are my references. Thank you to listen to me, and sorry for the how can I say, sorry for my
technical problems. Yeah. Okay, no problem. Thank you very much for your valuable contribution to our webinar. It was a very nice presentation. Sometimes there will be some technical problems like that.
But disconnection. Yes. For disconnection, I'm very sorry.
It is the normal for the webinar sessions. So I cannot see any question for you. So let me, yes, okay. I would like to thank you again. So close the